Ever get that sinking feeling when you're handing in a math test? You know, not sure if you totally mix up a step somewhere.
Oh, yeah.
Like, what if there was some kind of AI that could not only, grade your work, but actually like point out exactly where your thinking went off the rails?
Oh, that'd been nice.
I know, right? Well, that's kind of what we're diving into today with this paper, MathMistake Checker: a comprehensive demonstration for step-by-step math problem mistake finding by prompt-guided LLMs.
Catchy title.
Really rolls right off the tongue.
It does.
But seriously, this one is like, it's packed with potential, for how we learn and teach math.
It really is. This paper, it lays out a system that could not only automate grading, which would be, a huge help for teachers, but also give like super detailed feedback to students.
Right.
And that could like pave the way for more personalized learning, especially for, those really complex multi-step problems.
It's the ones we all dreaded. Okay, so let's break down how this MathMistake Checker actually works. The paper describes a two-stage system, right?
Right. First, you've got the OCR module, optical character recognition.
Right.
But it goes way beyond just reading the text.
Okay.
It has to segment all these different types of content, understand the layout, even figure out the order of all those handwritten steps.
Which, let's be honest, can be a total mess.
Oh, absolutely. Especially with some of the handwriting I've seen.
You're telling me my chicken scratch in high school was legendary. So how does the AI even make sense of all that?
Well, imagine an archaeologist, meticulously piecing together these fragments of some ancient scroll.
Okay.
They're not just deciphering the language, but they're also understanding the context and the sequence of all that information. And this OCR module does something very similar.
Wow.
It can untangle even the messiest handwriting and reconstruct the student's thought process.
That's really impressive. So, okay, once the AI has deciphered all of the students' work, what happens next? That's where the grading magic happens, right?
Exactly. And that's where the power of LLMs come in.
LLMs.
Large language models. They've been trained on just mountains of data.
Okay.
And they can be used to, predict those correct answers and compare them to the student's response.
But it's not just a simple right or wrong, is it? The paper talks about this pedagogical chain of thought prompting.
Yes.
What's that all about?
So that's a really innovative part.
Okay.
It's think of it this way. It guides the LLM to break down the problem-solving process step by step.
Okay.
Just like a teacher would.
Right.
So instead of just saying hey, this answer is wrong, the AI can actually understand the student's reasoning and figure out exactly where their logic went off track.
See, that's where this gets really interesting for me. I remember struggling with algebra and just getting a big red X next to a problem.
Right.
Wasn't helpful at all.
Not really.
I needed to know why I was wrong.
Exactly.
And it seems like this AI could give students that aha moment, that deeper understanding of the concepts.
Absolutely. It's about moving beyond just grading to actually facilitating learning.
Right.
It's having this personalized tutor who can zero in on your mistake and then explain that concept in a way that makes sense to you.
It's like a personalized math tutor.
Exactly. And this could have ripple effects far beyond just individual students.
Right. Think about the impact this could have on classrooms, online learning platforms, curriculum development. It's kind of mind-blowing.
It really is. And to fully appreciate how far we've come with this, we need to take a quick trip down memory lane.
Okay.
You remember Scantron machines? Those early computer-aided instruction systems?
Oh, yeah, I vaguely remember those. Pretty basic compared to what we're talking about now.
Yeah, exactly. Those were essentially just glorified answer checkers.
Right.
This new approach, it's like a giant leap forward. It's not about just comparing answers, but understanding the thinking behind those answers. It's a much more nuanced and personalized approach to assessment, which really reflects all the progress we've seen in AI and machine learning.
Okay, so we've established that this MathMistake Checker is pretty revolutionary. I'm really curious to hear some of your novel notions. You always have such fascinating insights. What are you thinking?
Well, here's something to consider. What if we use this MathMistake Checker not just for grading individual students, but to analyze patterns of mistakes across entire classrooms, schools, or even districts? We could use this system to identify those tricky concepts that, consistently trip students up.
Yeah.
It would be like taking the pulse of mathematical understanding, but on a much larger scale.
That's a really interesting idea. Instead of just focusing on individual learning gaps, we could use AI to pinpoint like systemic weaknesses, in math education. We can figure out which concepts are consistently like causing problems and target our teaching efforts more effectively.
Exactly. It'd be like having this massive diagnostic check on our entire math education system.
Wow.
Allowing us to address those fundamental gaps in knowledge that, hold so many students back.
Okay, so we're using this AI to analyze patterns of mistakes and improve teaching strategies. But how does the MathMistake Checker actually work on a technical level?
Yeah.
I'm curious to get under the hood and see how the AI actually deciphers those handwritten answers.
So that OCR module we talked about,
Right.
the one that can read messy handwriting,
Right.
it actually uses this multi-phase pipeline to process those, mathematical expressions.
Okay.
It's not just one algorithm doing everything at once. Think of it like an assembly line,
Okay.
where each station has a specialized task.
An assembly line for understanding math. I like that analogy.
Yeah.
So what are the different stations in this pipeline?
Well, it starts with something called text-line semantic segmentation. This is where the AI separates the different types of content within the handwritten answer.
Okay.
It can tell the difference between, numbers, variables, operators, even those little doodles in the margin that students love to add.
I remember doodling a lot in my math notebooks, more than I probably should have. So the AI can tell the difference between like a variable and a poorly drawn stick figure. That's pretty amazing.
It is, and that segmentation is crucial for the next step, which is specialized text recognition.
Okay.
Here, different AI models are used depending on what type of content is being analyzed, for example. One model might be optimized for recognizing handwritten numbers, while another one's better at deciphering mathematical symbols.
So it's like having a team of expert handwriting decoders, each one specializing in like a different type of mathematical language.
Exactly. This targeted approach helps improve both the speed and the accuracy of the OCR.
Right.
But there's more. The system then moves on to document layout analysis,
Okay.
where it figures out the spatial relationships between all those different elements.
So it's not just reading the symbols, it's understanding how they all fit together on the page. It's like putting together a jigsaw puzzle, right?
Precisely. The AI can even reconstruct things like tables or diagrams, maintaining the original format of the student's work.
Okay, that makes sense. But what if a student doesn't write their steps in a perfectly logical order? What if they jump around a bit?
That's no problem for this AI. That's where order detection comes in.
Okay.
The system uses a technique called a pointer network to figure out the correct sequence of steps, even if they're written out of order.
So even if a student's thought process is a bit jumbled, the AI can untangle it and figure out what they were trying to do.
Exactly. It's like having a detective, who can piece together the clues and reconstruct the sequence of events.
Right.
By this point, the system has essentially transformed a jumble of handwritten scribbles into this structured digital representation of the student's work.
That's incredible. The AI has basically learned to read and interpret math like a human teacher. So what happens next? This is where the actual grading happens, right?
Yeah. Right now, it's time for the grading module to take over. And this is where those powerful LLMs, large language models, really shine.
Okay, so how does an LLM actually go about grading a math problem? Seems like a pretty complex task.
It is, and it involves a three-phase process.
Okay.
The first phase is called regenerate and predict.
Okay.
The LLM is given the problem statement and the initial steps of the student's solution.
So the AI is trying to predict what the correct next step should be based on the student's initial work.
Exactly. It's like the AI is trying to solve the problem alongside the student, anticipating what the next logical step should be.
And then what does it compare its prediction to what the student actually wrote?
You got it. That's the extract and compare phase.
Okay.
The LLM analyzes the student's response for that step, pulling out key elements and comparing them to its own prediction.
Okay.
If there are any discrepancies, they're flagged as potential mistakes.
But wouldn't a mistake could be anything from like a simple arithmetic error to a deeper conceptual misunderstanding?
You're right. That's where the final phase, evaluate and comment, becomes crucial.
Okay.
The LLM goes beyond just spotting discrepancies. It actually assesses the student's reasoning up to that point.
So it can tell if the student made a simple calculation error or if they're fundamentally misunderstanding the concept.
Precisely. And remember that pedagogical chain of thought prompting we discussed earlier?
Yeah.
This is where it really comes into play.
Right.
The LLM can pinpoint the specific error in reasoning, helping the student understand exactly where they went off track.
So it's not just about giving a grade, it's about providing meaningful feedback that can help students learn and improve, That is a huge difference from those old Scantron machines or even some of the online grading systems we see today.
Absolutely. This approach represents a shift from simply assessing answers to actually understanding the thinking behind those answers. And that's a crucial step towards creating a more personalized and effective learning experience.
This is really making me rethink like all the possibilities for AI in education. It's not just about automating tasks, it's about creating tools that can like really understand how students learn and give them that personalized support.
Yeah, exactly. And this math mistake checker, it's really just the tip of the iceberg.
Yeah.
It opens up so many possibilities for how we can use AI to make learning and teaching better. Remember those novel notions we were talking about earlier?
Yeah.
This paper really got me thinking.
Okay, I'm all ears. Let's hear those innovative ideas.
Okay, so here's a thought. What if we took this technology beyond math?
Okay.
What if we developed AI systems that could give this level of like detailed, personalized feedback in other subjects like writing, coding, or even music?
Now you're talking. Imagine getting instant feedback on your writing style, your coding logic, or your musical technique.
Right.
It would be like having a personal coach for every subject.
Exactly. And these AI coaches, they wouldn't just be grading your work. They would be understanding your thought process, figuring out your strengths and weaknesses, and then tailoring their feedback to what you need.
It would totally change the way we learn, letting us go at our own pace and really zero in on the areas where we need the most help. It's like the ultimate personalized learning experience.
It really is. And it's not just about, individual learning either. Imagine the insights we could gain by analyzing patterns of learning and mistakes across entire classrooms or even school districts.
Right. We could use AI to pinpoint those common stumbling blocks that trip students up, and then teachers could adjust their strategies and create better curriculum.
Exactly. We could build this feedback loop where the AI is always learning from the data it collects, becoming even better at helping both teachers and students. It would be like this constant cycle of improvement.
It's exciting to think about how much of an impact this could have on education, but let's not get ahead of ourselves. This technology is still pretty new, and there are definitely some challenges we need to consider.
Of course. Creating these AI systems is super complex, and we need to be really careful about biases in the data we use to train them. Plus, we have to make sure these systems are accessible to all students, no matter their background or resources.
Those are some really important points. But even with the challenges, it's clear that AI has the power to completely transform the way we learn and teach. It's not just about doing things faster or more efficiently. It's about helping every student reach their full potential.
I totally agree. This math mistake checker is just a peek into the future of education, a future where AI can be this amazing tool for personalized learning, understanding, and growth.
It's a future I'm really excited to see. And as always, we want to hear from you, our listeners. What do you think about the potential of AI in education? What are your hopes or concerns about this technology?
Share your thoughts with us on social media. Let's keep talking about this and explore all the possibilities together.
Thanks for joining us on this deep dive into AI and education. We'll be back next week with another fascinating paper. Until then, keep those minds curious and those algorithms humming.